in a much efficient way. How does virtualization help an organization? Simply put, virtualization helps the organization purely because we decouple the physical hardware from the operating system and application, right? So, I'm trying to make it very concise because the topic is SDDC. So I'm trying to just talk about virtualization in 3 slides, server virtualization in 3 slides. So the notion is that I want to decouple my physical hardware from the operating system and application and run as many instances on top of a physical server, which is on a VMware physical on a server which has the VMware hypervisor. Now, I have customers in India who run sometimes close to 100 virtual instances on a single VM. Now, think about the server consolidation ratios. Think about the power cooling savings that customers have. I work with the banking sector, and I have a customer who runs production virtual machine, virtual instances, production virtual servers, and the consolidation ratio that he's achieved is 70:1 in some instances. Right? So that is the power of virtualization, reducing your physical server footprint in your. To sum it up, server virtualization was all about decoupling your physical hardware from the operating system and application, right? And just sliding in that VMware hypervisor on top of bare metal server and running as many parallel instances of virtual servers on top of it. This is how this was called the logical partitioning in the Unix mainframe. Capabilities were never there in the x86 world, and we've just brought those capabilities in the x86 world, and at the same time ensuring that each operating system and application that you see on the screen is completely independent, or each instance is completely independent from all the other instances that are there on that single physical server. So if a single server fails, it does not really matter because a single virtual instance fails, it does not matter because all the other instances are completely isolated from each other, right? And even we have high availability from a physical server perspective. So if you're thinking, what if the server fails, then I have multiple instances going down? No, because we have high availability, and the virtual machines the virtual instances would come up in a different server if you have multiple servers in the cluster. So, if you now that I've spoken about server virtualization, and we all understand that every data center today has a footprint of virtualization in India, and the proof lies in Gartner. I mean, they are the most trusted research firm across the world for IT organizations, right? And if you look at this chart, it clearly shows that the number of the percentage of workloads. Percentage of virtualized workloads are increasing, and today, around in 2013, 60% of the workloads are virtualized, and 80% of them are actually running on VMware. So you have, in fact, in India itself, you have a lot of customers who run production workloads on VMware, and the capabilities and the benefits are all well known. We would continue to see this this rise of virtualized workloads going forward. In fact, what we've already started seeing is business critical applications running on VMware. And if you look at the software-defined data center that I'm going to talk about, software-defined data center talks about business critical applications running with confidence on VMware platform, right? And this is going to be the reality going forward. You will have a lot of virtualized workloads, and you need solutions to deal with those, right? So when I talked about, I said that customers or IT organizations today are talking about delivering IT as a service. We as consumers have, so just to give you an example, phone, like all of us are smartphones users now, and what do? We just go to, for example, if you're an iPhone user, you go to iTunes and you just download an application that you want, and you have it on your phone. You pay for it. It's completely self-service, catalog based, right? So what if I could bring that power of iTunes to IT? and deliver IT as a service, where you have a catalog and you have a self-service, the power to self-service, and you have policies driven, written on top of it, right? So the whole idea is to empower IT as a service. Very similar to iTunes, right? Instant gratification. You want something, you have a catalog, you select something that you need for, and that is what IT as a service is all about. And so we've from an organization, if you look at it, like we want to redefine efficiency and agility through software-defined data center. We are working on these 3 core areas, and the first one being redefining efficiency and agility through software-defined data center. The second one is everyone is talking about cloud. Private and public cloud have to coexist, and if they have to coexist, if private and public cloud have to coexist, then you need a solution that gives the end user, gives you the power of choice without sacrificing security and control. So you need to look for a solution that gives you that choice, right? Without you having to compromise on security, control. It has to be simple. It has to be, it has to be a piece of cake for you to do it, right? So that is the whole idea about providing you choice in the hybrid cloud, which is the second core area. And the last one, which is not part of the discussion today, is empowering the workforce mobility, empowering workforce mobility. And so I'm just to leave a thought, right? So if you look at any IT organization today, you would see a proliferation of devices. When I say proliferation of devices, what do I mean? You no longer have a very Windows-centric, world. You typically today live in a multi-device and bring your own devices are becoming a reality. So IT today is faced with the challenge of managing multiple devices, your MacBooks, your Android devices, your Windows legacy, your Windows laptop and desktop. So and we go with pointed solution for each solution, right? You have pointed solution for each device or each application, each operating system that you have out there. But what if I can break that? Or what we want to focus in this area is all about. Imagine if I don't care what which device the user is using. The end user could give choice. He can use any device that he wants to, right? And I want, rather than focusing on, rather than having a device-centric approach, I will follow the user, and not the device, right? So I'll have a common solution for all devices, and the policies are tied to the user and not the device, right? The policies are tied to the user and not the device. That is the point that we're making in the third strategy, right? So these are the 3 strategies. I will, for today's discussion, we will be focusing on software-defined data center. How do we increase? So we've made data center efficient and agile with server virtualization. How can we redefine efficiency and agility? I'm going to cover next and for the remaining part of the presentation. So it's very clear, right? If you look at I talked about server virtualization, right? Now the whole idea is that what if I can take that same principle that we had for server virtualization and push it down to the entire data center, right? So what if I can take the same principles of server virtualization and do that or replicate that for every other object in the data center? So what are the other objects in the data center? You have enterprise class storage boxes, you have networking devices, which is routers and load balancers and firewalls and all that. And what if I can just take those same principles of server virtualization and put it to and push it down to other components of the data center? What if I can abstract, pool, and automate and deliver this unprecedented value for customers? That is the idea that we are trying to say, right? We gave customers a lot of. If we made data centers a lot efficient with server virtualization, and we want to do that. We want to follow the same principles apply the same principles to other components of the data center and make the data center more efficient, right? Now, for that, right, we coined this term called as, and how do we do that? We do that with purely by software-defined data center. So when I say software-defined data center, what does it mean? Right, software-defined data center basically means all infrastructure is virtualized and delivered as a service, right? When I say all infrastructure, meaning your server, your storage, you want to give it to them as a service. You want to completely automate that process, right? So I'm just gonna. I'm just having a little problem with I'm back. So just to give you an idea of how data centers were in the legacy data centers. So if you saw the centers, they typically, in fact, had pointed solutions, or let's say it was a siloed approach, right? When I say siloed approach, meaning what, right? It was based on applications. So you had this, say for Oracle, you had this Oracle stack. You had an Oracle stack. For SQL, you had a SQL stack. So it was hardware was segregated based on business units as well. Sometimes one single business unit would have their own set of hardware devices in the data center. A different business unit would have its own set of hardware devices. It was not pooled. It was not shared. So, and what did this lead to? This led to inefficient, usage of hardware resources in your data center. But what do you want to do? I mean, you want to make data centers more efficient with software-defined data centers. So what do I want to do? I want to really break this siloed approach, right, and deliver it as, what do you say? I want to first extract the hardware resources, right, remove the heterogeneity, bring in the homogeneity, right, and then pool these resources and give it to business units, multiple business units, which can be purely SLA based, right? And I want to then also ensure that I have taken the same principles that we did for compute to the other components of the data center, which is storage and network, and have management, automation, cataloging, self-service being done in an automated fashion, right? That's the whole. So with that, let me talk about software-defined storage, right? So what is software-defined storage? When we said that we did a lot of compute virtualization, and compute virtualization gave me higher consolidation ratio, saved me a lot of money in my data center. What is software-defined storage? I mean, how do you look at software-defined storage? So if you look at what has happened in the data center today, virtualization has changed the storage workload. What do I mean by that, right? So if you looked at the older legacy way of doing things, what did we have? In the physical world, we had a single server, right? And that single server could have a LUN being presented to that single server and that LUN could come out from a storage device, right? So we had a 1:1 mapping from the application to the storage LUN, which out here says data store, right? 1:1 app to data store mapping. Now, this was very easy to maintain purely because it was predictable and it was static workload. So if I had a business critical application running on a physical server, let's say for instance, that physical server, I could put it on a LUN on a separate spindle and ensure performance, right? Because I know that this LUN won't be shared by any other physical server. So I will to an application and server, so it's predictable, it's static workload, I can ensure life is simple. But then came virtualization, and virtualization changed the entire storage landscape. Why? Why do I say that, right? Because now you have a single LUN that is coming from a storage array, and that single LUN is visible to the server on which the VMware hypervisor is running. Now this what do you say? This LUN that is presented to multiple, we call it the vSphere servers, could have multiple VMs running on it. So if you see that, see the image on the right. You could there are virtual instances running on top of the hypervisor. Now each virtual instance is nothing but, we call it a VMDK file, right? So a single LUN, so if you see a single LUN is made visible to a vSphere server, and on a single data store you could have multiple VMDKs running, or say multiple virtual machines running. So in comparison to the physical world, it is a N:1 app to data store mapping, right? So on a single storage LUN, you could have multiple virtual machines running, and these are random workloads because we have a concept of storage vMotion. We have, a storage load balancing feature available today. So so this is completely mobile in the sense that on a single data store, in, coming, going out. So it is very random. How do you ensure performance guarantee in a virtualized environment is what we are going to talk about, right? I mean, virtualization has brought in a lot of opportunities in the storage space as well, and VMware is committed to deliver those services. So what we've done first, the first thing that I want to talk about is we've worked with our partners, our storage partners, which is EMC, NetApp, IBM, and a lot more, and we have come up with something called as virtual volumes. Now, what is virtual volumes? Basically, it means that today, as I said, so if you go back to that old, the previous slide, it showed a storage LUN on which multiple virtual machines were running, right? So the storage was not aware of how many VMs are running, how many VMDKs are there. The storage just knew about the storage LUN that has been configured on it, right? So what does that mean? It means that the existing SAN NAS were not VM aware. What we are going to, so we are working with our partners very closely to make sure that the existing SAN and NAS system become VM aware. That means that the storage system will understand VMDKs has virtual volumes. Now imagine, think about it, right? I mean, if each VMDK becomes a virtual volume, the benefits that you get out of it is tremendous. It's because now you can do array-based storage operations, right? You can do snapshotting, cloning, etc. on an individual VM level, which means on an individual virtual volume level. Because earlier on, when we did not, when the NAS and the SAN system were not VM aware, you were doing storage operations at the LUN level, right? And in a single LUN, there can be multiple VMs or multiple VMDKs. Each VM is a VMDK. Or multiple VMDKs. Now I'm saying that each VMDK is a virtual volume which the storage understands, which your existing SAN and NAS system understands. So all the storage-based operations like snapshotting and cloning can be done at a virtual individual VM or a virtual volume level, right? This makes the storage highly efficient, and this works with all your existing storage system that is out there. So we have a broad ecosystem to support this kind of concepts, right? So virtual volumes is going to become a reality. This is one. What is the second one, right? So if you look at the older server, so what happened with typically, server virtualization talked about, if you want the benefits of, high availability and load balancing, you need to put all your workloads on. When I say workloads, I mean virtual machines. You need to put all your virtual machines on shared storage, right? And what happened because of that was the local disk that were there in your servers were really underutilized, right? But today you also have servers that are coming with SSD drives. Now if they are coming with SSD drives, how can I make much better use of that, right, is the question. I mean, I don't want to waste my SSD, that comes with my physical servers. So what we do with vSphere flash read caches, basically think about it as a caching technology which acts like a server flash. So what does that mean? It means that just like in the compute world, we could create resource pools of, say, CPU and memory. I can create a resource pool of, say, a flash pool. Now, what does this give you? This gives you critical application, because get my boost. Like, it's like you have on a storage controller, you have storage controller cache. Think about it, servers running with server cache, right? Or we call it server flash. So we create this flash pool, and people are putting their business critical applications on VMware, and imagine leveraging this flash pool to accelerate the performance of the business critical application that is running on top of your vSphere server, right? So this enables efficient use of server flash in virtual environments. And the best part about this is that this is completely independent. So once you run a virtual workload on top of the vSphere server, I don't really need to put any agents on the virtual machine. When I create the virtual machine, I will have policies set on it. I can say, for example, it's all going to be policy based, right? So I'll say that assign 5% of flash pool to this particular virtual machine. And when I create this flash pool, and basically I get this performance boost because I'm getting all my IOPS that I need from the flash pool rather than going to the storage, right? And without requiring to install any agent on the virtual machine. Just give me 1 second. I'm just gonna fix my. Yeah. So, what are the other features that we have in software-defined storage? Now think about it. As I said earlier, we were always dependent on shared storage, right? Because we wanted the capabilities of high availability, we wanted load balancing for our virtual machine. So we never put any server, as you know, is shipped with local disk. Now, today they are not just local. Today a server could be shipped with a mixed match of SSDs and hard disk, which is your SAS and SATA drives, right? Now, what is virtual SAN in that case? Think about it like VMware is entering into the storage domain as well, right? What we are going to do here is we are going to, let's say in a cluster you have 8 ESX servers. I'm going to pool the internal drives of all these 8 ESX servers, like if you see the graphic, and I'm going to create a clustered vSAN data store. Pull the internal drives, which can be your SAS drives and your SSD drives from each physical server, and group them together to create something called as a clustered vSAN data store. Now, what does this give you? This gives you the benefit of using your local drives, and this local drives put all combined together looks like a storage. It looks like any other SAN NAS box, and gives you all the capabilities like HAV, for what you needed shared storage for in the first place. Now that is something, right? I mean, if you think about it, we are bringing the benefits of an enterprise class storage or to your servers, right? We are giving that capability to servers, right? Taking all the local disk of each server across servers, pooling it together to make it look like a storage box for the entire cluster, right? That is vSAN. Now virtual and it can be created from a mix of solid state drives and hard disk, right? And again, this is all going to be policy centric storage, and we can use SSD drives as well, because SSD drives can act as a caching place, right? So if you look at most of the newer application, the legacy was different, but if you look at all the newer applications, like when you talk about big data and Hadoop, we are talking about scale-out architectures, right? And in this kind of an approach, when you're talking about scale-out architecture, applications requiring scale-out architecture, a virtual SAN would fit the bill, because you can take the capabilities of SSD cache, vSphere flash read cache that I talked about, and ensure the performance to the modern age application that we are talking about, right? And if you can, so what is the benefit of using vSAN? As I said, it is bringing those SAN, giving you that SAN capability from all the servers that you have today in your data center. Second of it, it is significantly lower in TCO for comparable performance compared to an enterprise class storage. So if you want to begin slow, you want to take those baby steps, you can think about putting your test and dev environment on the local on the vSAN, right? And see the benefits, see the performance that you get out of it, and then start putting your mission critical application as well, right? So vSAN is going to be the next, let me put it as a word, as server class storage for your environment. Then